Hello everyone, welcome back to my Unreal Engine open world tutorial series. So in this episode I'm gonna further work on this jumping part, so the predictive jumping part. So as you can see here, now this character smoothly transition from by jumping up to this upper ledge and moves continuously without any speed interruptions like this. So even if I increase the height of this object, it will work. Oh, like this. So it detects where it should go, and actually previously I was using move component to method, but because of that the character's speed is interrupted, the velocity is interrupted. So therefore instead of that I'm going to use the character launch method here. So the speed of the character will be interrupted minimally compared to the previous approach. And this episode is sponsored by these generous patrons. Thank you very much for the support you guys are giving me. Okay, so let's continue with jumping. So at the moment if we jump like this, the character can go like that. And what happens if this is too much, a little too much? Still it can, but we should implement hang on the ledge and then go back. And also what happens if I jump like this? Oh. For some reason if I try to jump the other way, it doesn't work. Let's see why. See, I pressed space but still it didn't work. What could be the reason? Okay, the reason is I have this do once node here, which I put there to prevent double jumping, because the character should not be able to jump while it is already on the air. Alright, now that I think about this, I don't think I need that, because I changed the movement state to jump in here, and if the movement state is already jumping, I can't do another jump. Alright, so I'll just ignore this to once node. Because I changed that part later on, I later on added those moment state part. Oh, now it didn't do anything. Ah, right. Okay, I think one more fix. I think I should decrease the time of the second of the jump in animation I use here, this jump one, because I play the full length of that one, I kind of feel like the character stops for a moment. Is that the case though? Because here I don't see character stopping. This is the final frame. Okay, let's check again. Alright, maybe the blending out time, it is 0.25 linear here. What's the value for this one? 0.05 linear. Okay, then what if I do like this? Let me copy this node and here, instead of this montage, I'll play this one first with the play rate 0, and starting section I'll keep none, because then it will start from the beginning. And here, now that I call onLand function this part, it will take care of this ending part. Let's see. Oh no. Why is that? Alright, anyway, that approach is not working, so let's stick with this one. But if I let's see, what if I reduce the time of this one a little bit, only to this point? That means start time is 0 and end time is 1. So instead of start time 0 and end time to 0.69. What if I do that? Let's see. Still no. Why does it stop in there? Maybe the character is actually stopping there. Let's see. Let me revert this change back to 1. Oh, back to 1. In the tick of the character, let's print the velocity so that we can see if there is actually a reduction in the velocity. Yeah, there is actually a velocity reduction. So how to deal with that? We need to deal with that in order to have a smooth transition from the point. Okay, now that we know the problem, let's see how to solve it. So simply setting set velocity will not work here. So but there is another function called launch character. Yeah, this one. Let's try that. So my character's speed, if I'm doing a jumping, it should be running 600. Okay, get forward vector, no, get actor forward, and then multiply it by running speed. Or do I have a get speed? No. Let's set override. Let's see. Still it didn't work. It stopped. Didn't work. How? Okay then. So instead of trying to make it work with this move component, let's try to make it work with this only with this launching. So yeah, this is what I'm suggesting. Let me put this aside for now and connect this directly here. So I'll keep the okay, let's get the forward vector. No, we don't need the forward vector. So here I don't need the running speed also. Here I'll add an z velocity that would be enough to climb up that ledge. So for now I'll try something like 100 and see if it works. For example, I need to calculate that z velocity manually, but just try if I can get it work like this. Yeah, it can work. Okay, so now here what I do is calculate the distance, and using that distance I get a time. Okay, so now you within this time, in order to have that vertical length distance, let me draw a simple sketch. So let's say this is the current platform and this is where we're trying to go, and this is the distance. For this distance we spend t amount of time, right? Let's say this is t and this is h. So what should be the vertical velocity I need to have in order to climb this h amount while when this character do this horizontal movement? So this is actually s equals ut plus half a t squared type of a thing, right? Actually at this point u is equal to, oh, we can use this part to v equals u plus a t. Now we know t, we know a, that is gravity, minus 9.81, and all we have to, and v will be 0 at this point, so all we have to know is calculating u. That means u equals gt minus gt. That means the gravity minus into gravity into time. Okay, let's see if this works. So this is the time we are getting here, and gravity. Oh, can I get gravity? Okay, this one into this one. Let's add another power node into minus 1, and that should be our launch z velocity. Oh, wait a minute, we forgot one thing. So we have to use this this equation, because h is not considered here, so this is wrong. Sorry about that. So then u is s minus half at squared all divided by t. Now we should be able to calculate s with the trace distances. Okay, now how to let's collapse this, otherwise it would be a mess. Calculate z velocity. Now here this is t, and distance, oh, h is height we need to climb is this. What's the target point? Yeah, this one is the target point. That means here this is t and this is h. H is same as s, this one h. So now equation is the return value is s, that means this one, minus, so for this we need the square of t this one multiplied square of t multiplied by g and multiplied by half, that means 0.5, and reduce it from, subtract it from h, then get the result and divide it. Oh, here we should get only the, this is actually the target point, so h would be, let me, this is the actual location and this is, alright, h would be, let's do the calculation here. Get actor location, let's split it, and here also split it. Break. Then this one minus this one, this is the height, and it should go here, like this, and this one should be divided by, again, t, and that is the output. Let's see if that works. Right, it did work, and the jumping was also smooth as well. See, awesome. Alright, thank God it worked. Well, not good, because I did the calculation. So now do I have to call this? Let's try skipping that and see if everything works still. It is working. Oh, this time it didn't. The reason is, what was the reason? I was too late to jump. Yeah, this time I guess what happens is my capsule hit here. So yeah, actually that's not really a bad thing. I have to time my jump in properly, otherwise I will not be able to jump up. But the another thing is, let me move it down like this. That landing is too harsh. The reason should be, even though I don't call the custom on landed event, still it calls this. So I'll reduce the play rate of this one. Or what if I simply stop the jump montage? I guess I have to reduce this blend out time. What if I put 0 for both actually? Oh, that's not enough. 0.1. For this also 0.1. Maybe a little too much. 0.2. I guess that's alright. Yeah, that seems fine. Okay, so I'll stop this episode at this point, and next time I want to work on this jump down parts, and actually it wouldn't be much of a problem, and hanging on the ledge and climb up. So I already had those functions implemented before, but I'm not happy with the quality of those functions, so I'm going to implement those things next time. Alright, so this falling down thing would not happen there, because this part is meant only for, this method is meant only for smaller gaps like this. Okay, so thanks for watching, and I have released another project file version update about this object inspection method. And also, if you like to support my work, you can get the membership of my Patreon club. The link would be in the description below. And thanks for watching. See you in the next episode. Goodbye.